Jupiter is not a place you can land on. It is a destination where you simply descend forever. To understand this gas giant is to abandon our terrestrial obsession with solid ground and instead embrace a world defined entirely by movement, pressure, and internal fire. Recent data from the Juno spacecraft and the James Webb Space Telescope, JWST, have peeled back the colorful curtains of this planet, revealing that what we once thought were flat stripes are, in fact, towering three-dimensional architectural marvels of ammonia and water ice. Unlike Earth, where mountains and oceans create friction that slows down the wind, Jupiter offers no resistance. The planet is a laboratory of pure fluid dynamics. The iconic bands we see, the zones and belts, are superhighways of gas moving at hundreds of kilometers per hour in opposite directions. Because there is no solid crust to anchor them, these jet streams are fueled by a colossal engine of internal heat, left over from the planet's birth 4.5 billion years ago. The Great Red Spot, a storm that has outlived empires on Earth, acts as a vertical skyscraper of gas. While it has been shrinking in width for decades, researchers have noted a startling phenomenon. It is growing taller. It functions like a planetary heat pump, driving energy from the deep, hot interior into the freezing upper reaches of the atmosphere. As you travel deeper into the Jovian clouds, the physics of the universe begins to warp. Under the crushing weight of thousands of miles of atmosphere, hydrogen, the simplest element, undergoes a radical transformation. It is squeezed so tightly that its electrons are stripped away, turning the gas into a liquid metallic hydrogen. This metallic sea is the source of Jupiter's terrifying power. As the planet rotates rapidly, a full day lasts less than 10 hours, this liquid metal swirls, generating a magnetic field 20,000 times stronger than Earth's. This magnetosphere is so vast that if it glowed in visible light, it would appear larger than the moon in our night sky. As you travel deeper into the Jovian clouds, the physics of the universe begins to warp. Under the crushing weight of thousands of miles of atmosphere, hydrogen, the simplest element, undergoes a radical transformation. It is squeezed so tightly that its electrons are stripped away, turning the gas into a liquid metallic hydrogen. This metallic sea is the source of Jupiter's terrifying power. As the planet rotates rapidly, a full day lasts less than 10 hours, this liquid metal swirls, generating a magnetic field 20,000 times stronger than Earth's. This magnetosphere is so vast that if it glowed in visible light, it would appear larger than the moon in our night sky. Jupiter is more than a planet. It is a sovereign system, a mini solar system, where the king dictates the life and death of its subjects. The four largest moons, discovered by Galileo, are locked in a gravitational dance that creates internal friction, melting their insides and driving their evolution. Caught in a gravitational tug-of-war between Jupiter and the other moons, Io is literally stretched and squeezed. This tidal heating makes it the most volcanically active body in the solar system. It doesn't just have volcanoes. It has lakes of molten lava and plumes that shoot sulfur hundreds of kilometers into space. If Io is fire, Europa is ice and hidden water. Beneath a fractured crust of ice lies a global saltwater ocean containing more than twice the amount of water found on all of Earth. The tidal flexing from Jupiter keeps this water liquid, making Europa the primary candidate in our search for alien life. Larger than the planet Mercury, Ganymede is the only moon in the solar system with its own magnetic field. It likely contains layers of stacked oceans separated by different phases of ice, creating a club sandwich of potential habitats. The most heavily cratered object in the solar system, Callisto, is a dead world that has remained largely unchanged for billions of years. Because it is further away from Jupiter's intense radiation belts, it may eventually serve as a safe harbor for future human explorers. Why do we spend billions to look at a giant ball of gas? Because Jupiter is a window into the past. By studying the microscopic ashes of its atmosphere and the chemical signatures in its storms, scientists are learning how planets are born and how they die. The lightning on Jupiter, captured by Juno's sensors, isn't just a weather event. It's a discharge of energy fueled by an internal furnace that mocks the puny heat we receive from the sun. Jupiter reminds us that the habitability of a planet is a fragile privilege. We live on a world with a protective shield and a solid floor. Jupiter is a stark reminder of what happens when the shield is too strong and the floor is non existent. As we continue to receive data from our robotic emissaries, the question remains, are we truly alone? If life can stir in the pitch black oceans of Europa or survive in the high pressure clouds of the Jovian atmosphere, then the universe is far more crowded and far more wondrous than we ever dared to imagine. The Jovian system is not just a collection of rocks and gas, it is a complete planetary ecosystem, a haunting and beautiful mystery that invites us to look up and wonder.